right now. Okay, so this is it from my side for the introduction. I will now give the floor to Mix Cycling to share a lot of knowledge and a lot of updates regarding the Green Loop project. I will get back to you at the end of the session. Thank you all.
Thank you very much, Rita. Yes, nice to meet you. Now I share the screen. You see my screen?
Yes.
Okay. Thank you very
Yes.
much, and nice to meet you. Today we carry out in this external workshop some things about the bioplastic application, and for this time the subject is bioplastic innovation. We talk about our experience, in particular in the first part of the presentation. I talk about the possibility to use bioplastic and biocompound carry out in recycling in several fields, and I talk also the opportunity to know better the bioplastic. In the second part of the workshop, my colleague Angela carry out an exemplification of the use of this type of biocompound in mixed cycling activity, and also explain better what is the principal business of mixed cycling also for the market, in order to demonstrate a very important exploitation activity, also thanks to the green loop activities. I start with some consideration on the bioplastic formulation. It's very important to focalize our attention on the new strategy that is very important to bring in consideration when a new formulation is carried out. In particular, in order to obtain a very important project for the realization of a good with bioplastic, we must to put attention that the bioplastic is a plastic, but with a more sustainable, with a more high sustainability. In particular, now in the market, it's possible to have bioplastic with a feedstock bio-based. For this reason, we talk about bio-based plastic or biogenic plastic, or biological plastic. Also, this is three different names, but generally the best in nomenclature, in scientific nomenclature, the best name is bio-based plastic. When the sources, in particular of the monomer that we use for analyze the synthesis of the biopolymer, is based on a bio-based feedstock. In our experience, for example, mixed cycling, we work a lot with several different type of, for example, polylactic acid, polybutylene succinate, polyhydroxyalkanoate, and all of these different biomaterial present a bio-based feedstock for the realization. And this is not only the unique possibility. Another possibility in the bioplastics sector is the end of life biodegradable and compostable. In particular, we have the possibility to have bio-based plastic durable, okay, or bio-based plastic durable, not durable, but biodegradable and compostable. In mixed cycling, we work with both. And we have the possibility to obtain different advantages thanks to use of this different bioplastic. But in our experience, we put together bio-based sources on polymer and bio-based sources on filler. The principal aspect that is very important in the bio-based plastic application is the environmental impact. For this reason, we talk about a reduced carbon footprint when we use bioplastic, and a more reduced carbon footprint when we use also a bio-based filler. Another very important possibility is the additional waste management option, because when we use also a bio-based plastic with biodegradable and compostable activities, we obtain also an improvement in waste management due to the composting or organic recycling. When we talk about organic recycling, we talk about the possibility to obtain a biodegradable and compostable polymer. Bioplastic is also an essential part of the economy and represent now fast-growing innovative industries that present the possibility to decouple economic growth from resource depletion and environmental impact. Now, for example, when we use the fossil-based material, we have the risk to use a not renewable material for the obtaining of different component good. For example, in Green Loop, we talk about packaging closure in particular also. And thanks to the possibility to use bio-based plastic, we have also the possibility to reduce the environmental impact, but also the possibility to avoid the use of not renewable resources. Now in the market and also with experience, and thanks also to the experience of mixed cycling, we have three main group of bioplastic: bio-based or partially bio-based, not biodegradable plastic, such as bio-based polyethylene, bio-based polypropylene, or bio-based PET, and also other type of new bio-based polymer that is possible to innovate in the market, such as PTT, bio-based ABS, and so on, bio-based POM, and so on. We have also possibility to have plastic that present bio-based but also biodegradable and compostable properties, such as polylactic acid, PLA, polyrosylcanoate, the big family of polyrosylcanoate, and polybutylene succinate, the PBS. In particular, PLA represent 100% bio-based carbon content, and PBS represent more or less 66 percentage of bio-based carbon content. We have also the possibility to have fossil-based polymer, but with end-of-life biodegradable and compostable, such as PBAT, polyethylene adipate terephthalate, and polycaprolactone. For example, we know very well also this type of biopolymer, and for us, for example, it's very useful also to work with them because some of our customers use also application of biopolymer for biodegradability and compostability in end of life and for the waste management, for example, in packaging application. Clearly, now we have the big opportunity that in Europe we have also a very important standard, EN 13432, that is an harmonized standard that permit to certify when a biocompound, when a packaging or another good realized with biodegradable and compostable polymer can be biodegradable and compostable at the end of life. This is a very important standard that explain what mean as biodegradable and compostable, and also in a Green Loop project, for example, now is ongoing very important test also in the closure realized with the biodegradable and compostable compound realized in mixed cycling plant. Bio-based polymer from renewable resource can be biodegradable or not biodegradable. For the Green Loop application, we have used bio-based polymer that together with bio-based fill choose from with our R&D team present a possibility also to have a biodegradability and compostability, in particular in industrial compost. This is a very important scheme that I suggest to bring also and always in consideration. Please, when we talk about bioplastic, also from European Bioplastic Association, we talk about polymer that represent in the left part of this scheme bio-based carbon content, but not present biodegradability compostability in the left. We have the possibility to have bio-based plastic that present also biodegradability, compostability, and bio-based carbon content, such as in the right part. And in the last part, in the down part of the scheme, we have biopolymer with end-of-life biodegradable and compostable, but from fossil-based resources. Now the situation is very complex, but it's very important to know that the bioplastic is a very big group of material that permit to obtain now different good, rigid, flexible, more elastomeric. We have now a lot of new biopolymer that permit us to obtain very different good with different characteristics from mechanical point of view, from thermal point of view, from optical point of view. And before I have talked about organic recycling, clearly, when we talk about end-of-life biodegradable and compostable, we talk about the possibility to obtain a biopolymer that at end of life is transformed in compost. This compost permit to grow other plant, permit to improve the biorefinery resources, and permit to obtain a different monomer with bio-based carbon content. In this term, we have obtained a closing loop, and it's a very precious closing loop that with organic recycling is possible to obtain now. Thanks to new certification, we have a possibility also to certify the BCC, bio-based carbon content. And now in the market, we bring different bio-based polymer with percentage of bio-based carbon content between 20 and 40% or higher than 80%. With this type of certification from Austria. An example, different compound that we have obtained, but after Angela show also other one. For example, before I have talked about the possibility to obtain different performances with biopolymer. Thanks to biopolymer used in mixed cycling plant, we obtain a transparent biodegradable and compostable jar, for example, such as this. Starting from bio-based feedstock, we have obtained jar, but also closure in the same polymer with a different color in order to obtain not a transparent, but colored packaging. We have obtained also rigid plastic packaging for cosmetic sector and other type of applications such as bio-based PET for the obtainment of transparent component or biodegradable and compostable other type of, in this case, white, total white jar for cosmetic sector. Moreover, in mixed cycling, we use not only bio-based feedstock in biopolymer, but also bio-based feedstock in filler. Generally, filler used in biocompound in order to improve properties, to improve generally mechanical properties such as rigidity, or sometimes it's very the use of filler, in particular biofiller, can help also to reduce the polymer part in a new possibility to reduce an environmental impact, but also sometimes to reduce the price, and sometimes also in order to reduce the plastic component from synthetic sources. With these three different approach, in our compound, we work also with high percentage of biofiller until 30% in weight. And we start from biofiller such as for example, rice husk, for example, sugar, for example, a lot of other coffee residual of the plant working. We have several different example, and after also Angela show someone, and we have also carry out in this presentation some images from Green Loop project. In that case, we obtain closure for oil and for limoncello, starting from different molding in collaboration with Guala. We have obtained this type of injection molded part. We have realized a bio-based compound mixing together in a very dispersive manner different biofiller with different biopolymer. In particular, in that case, we obtain a blend of polyhydroxycanoate and pale ale. Clearly, now we have a lot of possibility to work. Some examples reported in this slide. Cork scraps now represent a very important resource to use also as filler, and we have used also this. Sugera is the brand of carry out for our filler, specific filler based on Scork. We have also the name of Lolla on the trademark for another our filler based on raised husk. In particular, the last one is also using the last compound and permit us also to improve also mechanical properties until also scratch resistance due to the bio-based sources of raised husk that is very similar to the silica-based material. Our equipment is this. We have an atmospheric plasma treatment that permits to uh, reduce the component, the dangerous component for the compound, in particular the odor part of the filler, and permit also to reduce the amount of water inside of the filler. Why? Because when we put the filler inside of inside of the twin screw extruder, this equipment of twin screw extruder is reported on that images. We have the very important aspect to use dry polymer and dry filler in order to obtain a very good and fine dispersion. Absolutely. And now we have a lot of work ongoing. For example, in Green Loop project, we choose to use not only bio-based feedstocks from vegetable, but we have used also polyhydroxycanoate family of biopolymer that present the possibility to start not from plant from resources from vegetable and so on, but the polyhydroxycanoate starting from the synthesis of microorganisms that realize this long chain of macromolecule that is called with the name of polyhydroxycanoate. In particular, we have focused our attention in polyhydroxycanoate PPHB, sorry, PHBH in particular. Polyhydroxybutyrate. In particular, now we have worked in a specific compound that guarantee to improve the biodegradability also until marine biodegradability. In the project, we are in any case interested to industrial compostability. For this reason, this type of test is ongoing this month. Clearly, the application for the market is a lot. Now we're focusing the loop project in packaging, but mixed cycle will work also in different application, also in durable good, and the market, the global production capacity of bioplastic now is improved a lot. In particular, the application flexible, we have the possibility to see in this figure is very high, but also in other one, agriculture, automotive, consumer good, and now, for example, we work a lot also with the fashion industries. The global production of bioplastic is improved starting from the last decade, and now we also, with our contribution, probably this market trend is increased. Some example of application of, for example, polyhydroxycanoate is this, but sorry.
Sorry, Marco, sorry to interrupt. We're having some struggle with seeing the slides. They're not very clear. I don't know.
Please, what type of slide?
They're not very clear. They're like unfocused almost. Is there something with your internet? It started very well, like the last few other slides. Very
Now,
unfocused.
now you should.
No.
Marco, you have a problem with connecting.
No, my Wi-Fi is I know all good. My Wi-Fi is good. Now I have exit from the. Now I bring the. You see my screen now?
Not now.
Okay. Now I bring my screen. But in any case, I have concluded. In any case, now I have concluded. I have the possibility to move my presentation to Angela in order to show what is the other application in mixed cycling, in particular with a focus of new opportunity in the market. Please, Angela,
Yeah.
if you want to, I close my presentation and move
Thank,
to Angela.
yeah.
Thank you, Marco.
Just a second. So I open it, and this is my first time presenting with Teams, so I might have just a second. I'll be right back. Do you see my screen?
Yes.
Yes.
Okay. Also, I need to present. Just a second. I'm sorry. Oh, there it is. Sorry. We've seen this. We've seen this. I have the wrong file. Sorry.
Non riesci, Angela?
No, I can't. Marco, riesci a condividere tu? Sorry.
Yes, sì.
Non riesci a condividere.
You see my screen? Okay, this is, you see?
Okay, we did it.
Yes.
We did it.
Ci sei?
This is my screen.
So that's Marco's screen, sorry, because I had the previous version of the file. For those who don't know me, hi, hello, my name is Angela, and I think that I'm one of the latest entries to the Green Loop project. I represent Mix Cycling Company. We're situated in the north of Italy, more specifically Briganza, which is in Vicenza. And I will talk about the more commercial part of our company. Thank you so much, Marco, for explaining our progress until now. And so basically, our objective is to give a second chance, so second life to the scraps. And we're mainly focused on biocircular economy. And we develop sustainable materials by exploiting properties of organic fibers and generating production from scraps. We're also a benefit corporation, and we mainly focus on bio and circular economy principles, which have the main objective of nobilitating organic scraps and giving life to the plastic. Wait, okay. So I will talk about our Green Loop collaboration until now. Though I sub-entered this year, Mixed Cycling and Green Loop project has been a remarkable journey for us. We've had an opportunity to collaborate with forward-thinking companies and people and minds all across the European world. And together, we've developed new strategies and skills for the bioeconomy. I see that we put the technology. So this is our patent process, which is MTP technology, in which we process the organic fibers and we prepare it for the extrusion. With this machine, we sanificate, we take away the odors, and using non-thermal plasma, we prepare the fibers on the right humidity and right properties so they can be mixed cycling together with polymers. Then if you can put the next slide with the biocomposites. Oh, thank you. So we have the carrier part, which is, I'm going to look at my screen because I don't know if anybody else has problems with seeing Marco's. I see it a little bit unfocused.
Yes. From time to time, it focuses and unfocuses.
Yeah. So we have the carrier parts, and which are the polymers that could be virgin, bio-based, recycled, biodegradable, or biodegradable combustible, which we focused on during this project. We used a lot of pH, ACT, and pH polymers mixed with mainly rice husk and cork, where we, together with our neighbor company, Guala, which is down the street practically, developed bottle caps for limoncello and for olive oil bottles. And we had some pretty interesting and good results. With the development of these new bioplastic, we can offer reduced carbon footprint, possibility for industrial composing, and in many cases, compatibility with current recycling systems, which means that after we develop a material, we can also determine its end life and communicate to the end client how they can get rid of it, reuse it, or recycle it. Some applications, other than the ones that we mentioned before, could be, as we said, food packaging, cosmetic, household products, such as the third picture, which is wine bottle holder. For development of this specific material, we also used vine sprouts, which helped us have that scent of wine when you bring out the bottle. Also disposable, like straws, pet toys, furniture, industrial, and also automotive parts. And so. Our work with Green Loop is a testament of what happens when innovation meets collaboration. We collaborated with a lot of universities, a lot of companies that managed to give us more of the technical support and certification support. We managed to get more insight on the market, and we are working towards a goal, which is to completely, step by step, obviously, start using bio origin polymers instead of fossil-based ones, and have more sustained plastic, and not make it a problem, but a solution for the future. And I feel like that's the end of my presentation. And thank you so much for listening. And I will pass a couple of words to the powerhouse of mixed cycling, which is Marco Vigato, who will have a few words, just organized it like that. Thank you so much, Rita.
Thank you, Angela. Thank you so much.
Okay. Thank you, Angela, and hello everyone. My name is Marco Vigato. I'm General Manager and Head of Communication and Marketing at Mixed Cycling. At Mixed Cycling, speak to Marco Scatto, we develop innovative bio-based material that combine high technical performance, strong environmental responsibility. My role involves to leading the strategic direction of the company, managing the brand's communication and marketing, ensuring our message is clear, consistent, and impactful across at the market, all markets, sorry. What drives me, connecting sustainability with storytelling, building strong partnership, that's really important, promoting and future where performance and ecologic go and in hand. I'm truly happy to have you're here with us today. Now I over to my colleague Marco Scatto, Research and Development, Angela Davidov, Customer Service. Okay, thank you so much to Green Loop team for today. Okay, Angela, introduce you over there. It's okay. Okay.
question, Rita? We are open also for question if someone
Exactly.
is.
I would say the same thing. If any participant has questions for mixed cycling, I can say that I visited your place and it's amazing and really interesting and saw all the pieces that you develop, and it's really, really interesting. Giordano?
Hi, everyone. Good afternoon. Thank you very
Hi.
much for the opportunity. The presentation was amazing so far, very interesting.
Thank you.
I would like to inquire something about the treatment you mentioned before. Was particularly curious and not sure if you can share this information with us. In terms of the fiber treatment, are we talking about alkalinization as the etching? What exactly you are talking? If you may share, of course.
We talk about the plasma treatment before compounding, or you're interested about the pre-treatment before compounding?
Yes, yes. How exactly, which routes do you use? Because for fibers, usually we are talking about mostly sodium hydroxide, but there are alternatives.
Oh, okay.
Right?
No, yes, clearly. Our pre-treatment before compound is a patent technology and is a dry technology without solvent. And with this possibility, we improve more the sustainability of our approach. We doesn't use solvent. And this is a dry process that permits us to avoid VOC contaminant, avoid another type of gases that if we reach with these gases the compounding, we have the risk during the compound to have vapor or other also gases that can be also a risk for swelling and so on. In any case, we work with a total vent open during the compounding, but we prefer to guarantee a pre-treatment for fiber, but also for powder. Now we use this type of our NTP, non-thermal plasma technology, because with this technology we avoid to work with high temperature during pre-treatment. Maximum of temperature that we reach is 40 degrees, and with this type of temperature is a plasma based on radio frequencies. We have the possibility to avoid thermal damagement of, for example, of thermolabel thermolabel molecules of the filler. With this technology, we avoid this. This is a mild treatment that permits us to reach a good feedstock for compounding. After the compound, in the compounding activity, we work with a temperature that the specific polymer need for the melt.
Okay. Thanks so much for the reply, Marco. Thank you so much.
Thanks to you for the interest, Giordano. Thank you very much.
Ricardo also has a question. I don't know, Ricardo, if you can turn on your microphone or you want me to read the question from the chat.
Yeah, of course, with pleasure. Yeah, I'd like to understand better the compliance regarding the PPWR, so the new regulation on plastic waste, and I know that because I've been involved in the discussion that the green loop solutions compile, but it would be nice also to share with our participants and this which are the main characteristics and the reason why these solutions are compliant with the PPWR. And from the point of view of mixed cycling, for me, for the follow-up process in the market, which kind of application you think with your solution will be interested for this PPWR regulation? So I don't know, maybe Marcus Cato has some.
Thanks, Ricardo. Thanks a lot for this question because it's very actual for the market. Now, during this year, 2025, European Commission show a very important, approve a very important regulation for the packaging, in particular PPWR, represent the packaging waste regulation. And with our material, in particular with the output of Green Loop project, a part of Green Loop project is focalized on packaging because closure is packaging. we have obtained a very important result in our opinion, because if possible, I reshare a slide. Sorry. Are you sure? Sorry, because I have a specific slide that help the question of Riccardo. Yes, this. I hope that you see. The role of bioplastic new packaging and packaging waste regulation. This aspect is very important also in terms of exploitation of a green loop project. And with our biopolymer and with our bio-based compound, we have the possibility to help the very important objective of PPWR, in particular in reducing of GHG emission, in particular, thanks to the possibility to reduce the carbon footprint during all the life cycle of the product. And for example, now in a specific article of the regulation is cited also biological plastic as an opportunity when the bio-based carbon content is declared. In our project, we declared until 90% almost of bio-based carbon content, because the polymer part used in our project, in particular in the Green Loop project, with the compound choose from mixed cycling, is represented in the filler part and the biopolymer part only bio-based carbon content. For this reason, I think that with the product obtained from the Loop project, we have the possibility to help a lot. Also, the result of packaging waste regulation, that I remember all the packaging field, all the packaging company must reach, because at the 2030, from 5 years, more or less, all the company that put on the market a packaging must be to have a recyclability, a recycled content, okay, but also the bio-based carbon content is very important, as is also declared in the regulation. Clearly, this is an opportunity, but an opportunity that permit to reach also the strict requirement of this type of regulation. For this reason, during the project, the new project, we have also carried out not only biodegradable and compostable testing ongoing now also in the final part, but also food content compliance in collaboration with the ESQ on our compound, clearly. I hope to explain to your
Thank
question,
you.
Riccardo.
Thank you, Marco. I leave the floor for. I see there are additional questions. Thank you.
Thank you,
Yes, we have here a question from Janos in the chat, which I read: how can be a material purely bio-based but not biodegradable?
Yes, some polymer can be also durable, but not not biodegradable or compostable, but with bio-based carbon content. For example, an example is bio-based polyethylene. When the ethylene utilized for the polymerization polyethylene, starting from bioethanol from sugarcane, and the extraction of from sugarcane of bioethanol. After this dehydration, we obtain ethylene, and with ethylene we carry out the polyethylene polymerization. And this is an example. In that case, the polyethylene obtained is not biodegradable, but is bio-based.
Thank you, Marco. We still have some time for additional questions. If anyone have any questions, feel free to turn on your microphone and ask.
Also, I would like to add that if someone after this meeting wants to reach out, they can also see the link that was in the invite, and we'll be happy to answer all of the questions and inquiries.
Giordano raised the hand. Giordano Bernadette is raising hand.
Yeah, me again. Sorry, guys.
Jordan.
The topic was very interesting, so I'm very enthusiastic about biomaterial, bioplastics. So sorry, I can avoid asking questions just because I'm very interested. Look, I found the proposal very nice about using waste residuals. I think that's a fantastic approach. I was wondering if by any chance have you run some sort of biodegradation tests or recyclability, the number of how much you can recycle these bio-based materials, right? Because when we talk about especially waste residuals, fibers, and also biodegradable polymers, we also experience the problems of the thermostability, especially when it comes to recyclability, right? So have you carried out any sort of test or assessment in this sense?
When we use the fiber for the polymer compounding, for example, we choose fiber with specific requirement clearly in order to obtain the final result, but also with specific story that is possible to talk. Some customer ask us the possibility to obtain an added value product for their waste, and we carry out a specific project with the bio waste from our customer. Otherwise, we choose as in Green Loop the best fiber in that case for the final requirement that we need.
Grazie mille, Marco. Ringrazio.
Grazie. Grazie.
Thank you, Giordano, for your question. Is there anyone else with questions for mixed cycling? We still have some time. Okay, I guess I will keep going. We are closing now the workshop. I want to thank the mixed cycling team. As I mentioned, I visited your infrastructure and it's very interesting and to see all the solutions that you provide. And I encourage everyone to contact mixed cycling when you're looking for a bioplastic solution. It's really, really nice. I will share my screen again. So for Green Loop, we also have 2 other external workshops scheduled or planned. In this case, the wood composite value chain will also be presented on the 5th of June. And then we will have a session about the biorubber solution in Green Loop, which is still to be decided on the date. So I encourage you all to pay attention to the LinkedIn page of Green Loop and to register to the external workshop in which you're interested in. Just to end the workshop, we have here a small evaluation survey about this workshop. It won't take more than 2 minutes to fill out, and I ask you all to complete it.
Just give me 2 minutes. Let the conference ending. I will get back to you. Just 5 minutes.
And after you're completing the evaluation survey, I can just thank you for your presence here, for registering, and for being a part of the first external workshop of Green Loop.
Thank you very much.
Thank you, Marco. Thank you so much. Okay, thank you all. See you in the next external
Thank you so
workshop.
much, Vika.
Bye.
Have a
Thank
nice
you,
weekend,
Cycling.
everybody. Thank you.
You too.
Thank you for all. Thank you so much.
Thank you.
Thank you very
Bye.
much for your attention.
Thank you.
Bye bye. Bye bye.
Thank
Thank you
you.
very
Thank you
much.
very much. Bye-bye. Thank you.
Bye. Bye.
Thank you.
Oh.
Bye, Ricardo.